Hello, I am Dr. Narasimha Malladi. We are here to reflect on Class 1 reading pages. When you reflect, basically you reflect on important points. So this is what I have done. You must have already read the reading pages as well as the reflection pages, and I am discussing on the reflection pages here. So Unit 1 you have, and Class 1, and this is the title. And Mechanics, study of forces and bodies, and Engineering is analysis and design, technology is process and maintenance. And you should know what a particle is. Any body can be considered as a particle if the forces are concurrent, that means they are all meeting at one point. Then the body will have only translation. Okay. On the other hand, if they are not concurrent, that is non-concurrent, or not meeting at a point, then the body tends to move with translation as well as rotation. Okay. Mechanics is divided into three broad categories. Okay. Then we deal with solid mechanics right now. Then even in there we deal with rigid, and again in rigid dynamic mechanics, engineering mechanics, it is known as statics is for static bodies or bodies with constant velocity, and dynamics is for accelerating bodies. Okay. And now the history starts with Galileo, okay, father of modern mechanics. Then Newton, the most important one is this, and then Einstein and Born. Okay. And first law, inertia. Second law, F is equal to about acceleration. And third law is about reaction is equal and opposite to action. This is used in the getting what is known as equilibrium equation. We will see that. And gravitational attraction, Newton's law, gives rise to this value of 9.8, which is an approximate one that is okay for engineering applications. Now, here we discussed about dimensions and primary dimension n, lt. Everything else is a derived one. Force is a derived one. Okay. Similarly, moment is a derived one. So this is the dimensional homogeneity. That means dimensions on the left should be equal to dimensions on the right. Okay. The developments leading to essential engineering mechanics. 17th century, Newton talked about laws of linear motion, single dimension. 18th century, after 100 years, Bernard Lamy, known by Lamy's theorem, he talked about parallelogram law of forces, okay, for a particle at rest and two dimensions. And after one more century, Gibbs and Heaviside did this. Uh, they invented the IJ case, that is unit vectors, to define a work of J, say Maxwell of Scotland. So there are people from England and USA and of course UK. There are most of them are from UK. Then this is Stefan Timoshenko, Russia. He is known as the father of modern mechanics. His books are still studied. He read with J.H. Young. And later 1950s, after nearly 15 to 20 years, J.L. Merriam and Byron Johnson introduced vectors in the books. Okay, and in 21st century, I have used polar coordinates extensively and simplified them. So call them sims. So it will reduce number of steps. We'll learn about them later on. So I talked about 5 sims and 10 types of. If you master them, the subject becomes very easy. So therefore, I wrote the book on them, and you are going to read it, and we are going to follow that here. Now let's come to the reflection number page 5, and we talked about scalars and vectors. Vector is one with a magnitude as well as direction, okay, shown here. And here we are doing it more clearly in 3 dimensions with an angle shown in the xy plane. And we are using a unit vector, okay, Cartesian polar coordinates, okay. So any vector can be used in terms of unit vectors. So therefore here it is shown in a plane. A point can be defined by x, y, or r theta, or we can avoid all this and use only r theta here. And when it comes to writing an equation, you write r x j like this, or r e theta. Okay, then how do you write it? You can write r e theta or r at theta, or at an angle theta. Okay, so e means at. Okay, now we study the understanding of a subject is uh, assessed in terms of questions and problems. Okay, here I define question is a single step question, and if it has more steps, it becomes a problem. But we are dealing with numerical problems here because ultimately that's what matters. Okay, no matter how much theory you know, ultimately you have to calculate and implement it. Okay, in the manufacture of a problem thing. Now, the fundamental thing is how to convert given information, given angle relative to any axis into an angle, polar angle means angle from the x. So the reference, the relative angle here is, relative axis angle is 90. So this is on the decreasing side, therefore I subtract, or on the clockwise side. Okay, clockwise side is decreasing, anti-clockwise increasing. So 90 minus theta, and this is a math card expression, and the advantage of writing this instead of a calculator is I can change this here. Okay, and say 9, let me say 8. Okay, and come outside and click. See, it has. So I can make it again back to 9. So this is the interaction. Okay, 50. And in doing this, I advise you not to change the font, because see, you can always tempted to say mathematical formatting and change the thing. Don't do that, because if you do that, it will mess up all the other fonts. Because I have done some fonts in big size, some in small size. Okay, so if you make a general statement here, it will mess up, and it messed up for me. So I'm doing this. I tried to do that before, and after almost 80% of the recording, I got stuck, so therefore I have to come back. So I don't want you to do that mistake right in the beginning. All right, so here I'm doing other problems, with reference to 80, increasing side add, and then here is also increasing side add, and here it is decreasing side, therefore 30. Okay, so you can say, instead of saying clockwise and then negative, I'll say increasing side, decreasing side, basically, you know what it is. Okay, uh, then this is a problem here. It says, so it gives three vectors, shown outward vector b30, it's already given, and all the angles are given, only two magnitudes are known. So then it says, this is how to solve it. Okay, also, so add them and equate this as sum to 0. Then applying sym3, which is called perpendicular component equation, LCE, to the line 30 and line 120, find A and B. And the same thing is explained in a different way. Sim3 is sine equation with subtracted line angle. So sim3 is used in about 80% of the calculations, therefore it's better you master it very well. Okay, so first thing is we add up this, blah, blah, blah. Then you got it. Okay. Then we are applying it. LCA, that is perpendicular component equation, line 30. So this line angle, this is the 30 is the line angle, line 30. So I am subtracting from everything. See, 120 minus 30. Ding, ding, ding. 30 minus 30. This becomes 0. You have to remember that. And 270. You don't calculate here. Computer will do it. Okay, then now you develop an expression. For that, you have to take this constant to the left side. So it is plus here, therefore it is minus, ding, ding, ding. And then here it is 120 minus 30 here. This ding, ding, ding is brought here. It is multiplying, it is dividing. Very simple. Okay. So then this is an expression, this is an equation. Okay. So therefore A equal to, if you, when you say type A and then equal to, bingo, it gives. Okay. All right. Next, you say do the same thing for other line 120. Now A see this becomes 0, okay, and then you can find out b. So again same thing, the type 1 remains same, I mean same in the sense, same as this basically with minus sign, okay. Then you do it, good. Now the advantage of doing this, okay, we can design, we can change the data and generate problems, but here we have given there is a still smarter way to do this. We will find out, okay. Now, so we have discussed individual what you call questions and then one problem. So now it is time to, we have, you have read it, and uh, now here and we have reviewed it. In fact, you have reflected, I reviewed it. Then now comes the prep tutorial, that is preparation tutorial. So the problems will be very similar, okay, so that you get a good understanding. Only thing is the values are different. So here it is given, and here I have given get answer in this space, etc. Usually in the examination, actual one, it won't be there because I'm giving instructions here. So I will use the small place to do this. This is the A and B. Okay. So A is, I know it is 90 and B is 30 is given. So I can write theta equal to, okay. So now this is in this, uh, let me go to the math format here, okay. Okay, B, then I write, so theta equal to, see, what happened. Okay, we moved it somewhere. Prep tutorial question 2. Okay, so I'll put plus here and then say theta equal to theta, and this is an I have to do it in the form of an expression, and then it is 90 degrees, 90, and then I have to put degrees here. I don't want to change the font, okay, in the before I do it, because if I do it before this, the whole thing will mess up, okay. Then minus, it is minus, and then uh, again this is 30, 30, and then I have to go to degrees, okay. I'm taking more time because I'm trying to explain to you. Suppose I want to show it bigger, okay, and then I can change the font, okay. I choose the whole expression, okay, then I choose the font. How do I do that? Math formatting. Suppose from 11 I have put 16, okay. So that's, it's clear to you now, but I should not, uh, then I'll take it away, okay. I'll take it away. So I, all right. So I go to the, I got 30. So here I'm changing, get, okay, 90 minus 30. Okay, the answer should be 60, right? Okay. If I get 60, I got full marks. If I did not, it will give you, otherwise it will give you a hint. Okay. Okay. And you can go to question 2, otherwise second attempt solution. So here is the box, okay. You put the solution. If you get, okay, very good. If you get 60, otherwise it will give you how it is gone, you got it. So here you said a is equal to 90, b is equal to 90, theta is equal to a minus b. See, then it will calculate like this, okay. So if you don't know, the program explains you to, but gives you half the points. Now, when once you follow this very carefully, you don't make those mistakes in the next problem. See, it's very easy. So the values are a and b are different. That's all. So you can get the answer. See, they are different. So you got a different answer. Okay. And again, here again a and b are different. Okay. So they are different, so got a different. So that's the advantage. If you write like this, you can see all you have to do is change this, okay. and then get the answer. Okay. Now, now here is a problem. So that means this is, it has more steps. So for outward vectors, all right, A 30, B 30, these unit vectors ignore some simplicity, and then uh, it is add them using polar vector notation, equating their sum to 0, applying sine 30. I change the wording a little bit because the same thing can be said in different ways, but it's the same problem that we have already solved as example. I particularly did this so that you can see how there I have done there, how I have done here. So here what it is it's already same thing reading polar vector equation. There I use the angle 30 directly, but I am using it as theta A, theta B, C, and theta C. Okay. So I am defining it like that. I want you to learn this way, and then it is asking to write the equation of subtracted angle. Okay, this is the PVC, polar vector angle, theta A, theta B, and all that. And subtract not theta A minus theta A, blah 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 here. If you do it right, then you can find the expression for it. Okay, all right. So you can write the expression here. I initiated, but you have to finish it. Again, you use the same expression here, PVC. Start subtracting B, then you have to complete it. If you do it right, you get the value of A properly. Now, after done this, okay, you check the value. If you get the right values, it is excellent. Otherwise, second solution. So that means you didn't get 12, so you give yourself 10. This is very important. If you cheat yourself, basically you get a feeling of, oh, I have done it, because this, unless I am not giving any value to this until you go to the final examination. So therefore, don't cheat yourself. Okay, you are self-assessing here basically, because if you do it right, you will know where to go and revise before the exam. Now here I have given the equation, and I have also given the diagram. Now I am asking you to get the expressions and all those things, get the answers. So you can do it here, or you can go back and correct them here. Okay. I have given the correct expression here, so you can do that. Suppose you didn't get that answer even then, that means you are making some mistake in the expressions, not in the equation. Okay. So when you are doing, so therefore I am giving the lateral correct solution. So I am doing this step, then I subtracted these things properly, then I wrote the equation. This is, you must be able to do this. If you do it right, you get the answer, bingo. Okay, if you get it right, you get the answer, bingo. So now let us assume I am a dumb guy, and I messed up everything. So therefore, even then I got my 6 points. So I will use this knowledge later on. How? So, so after the prep tutorial is over, now you have gone to the class. All this is done at home. That is reading, reflection, watching the video, and doing the prep equation. Okay. After my explanation basically. Okay. Do that. Okay. You went to the class, and your teacher, okay, explains everything again, same like a video. Okay, then you start with class tutorial. So therefore you are doing, and then again you do the 4 questions and the problem. Everything is done there. So this way you get a very good experience, and it is like having somebody by your side, like a music teacher. You know, if you say it wrong, she will or he will correct it. So that is why we prepared this to, so that you will get all A's in the final examination. And thank you very much for your patience and listening. And good day to you. Namaste.